OK， Good morning, thanks everyone. 那谢谢大家的参加。Then I think today the topic of this conference is the collaborative neuroscience, the convergence of the smart hospital and open data in brain research. And I think we start from Jack Lee to give us the opening. Hello, Jack. Okay, Jack,
okay,
we
can see you.
You are mute. Wait, we cannot hear you. Did you open your microphone? I think everyone know about Jack. I think during we fixed the connection problem, I introduced a little bit background about today's conference because we know the neuroscience is kind of popular research right now, and we have the TNI Taipei Neuroscience Institute and the ITRI. They also have done a lot of brain research. So I think it's important to combine all the smart people together. So that's why we hosting this conference. We are hoping to gather in all the smart people on doing the brain research.
Jack 那边还跟他说一下，他听。
Okay.
I think we will fix that the Jack connection later. 对，我们让沈副所。
Okay,
I think we will invite the 沈副所长to give us an opening remark. Thank you.
Okay. Good morning, every honored guest. It's so great to have this meeting to integrate the different multidiscipline capacity to aim for the brain research and also intelligent hospital establishment in all this field. I will stand by ICHIT BDL laboratories to thank 双和医院 and also all the guests to have this chance to make our team, to show our expertise and also to learn from the hospital expertise. In the near future, hope we have a very great project and also have great team to go ahead to have more experience and research and also honored in this field of brain research and digital research in brain and also intelligent hospital. Thank you all. Thank you.
Thank you, Dr. Shen, give us. And the second one, we will invite Professor Yong Guangdu. As we know, the Yong Guangdu is the president of the Taipei Neuroscience Institute. We will invite him to give us a remark. Thank you.
Well, thank you. Distinguished guests, colleagues, ladies and gentlemen, on behalf of Taipei Neuroscience Institute, I would like to extend our heartfelt welcome to all of the participants of this symposium entitled The Convergence of Smart Hospital and Open Databases in Brain Research. In recent years, there is a rapid development of using open databases in the management of healthcare system and conducting medical research. Therefore, it is extremely important that clinical scientists as well as basic researchers to be familiar with the using of open databases and artificial intelligence in their daily clinical and research works. Today's symposium is co-organized by the International Center for Health Information Technology of Taipei Medical University and the Biomedical Technology Device Research Laboratories of Taiwan Industrial Technology Research Institute. I would like to express my most sincere appreciation to Professor Minjin Lin. Without his effort, this symposium will not be a reality. I send you all my sincere best wishes for a most successful meeting. Thank you. And I need to apologize because I have prior commitment this morning, so I cannot stay with you through the meeting. Thank you.
Yeah, special thank President Tu. Actually, he's kind of very busy. Then he's 50 years the alumni gathering. But so I think he want to support this event. So yeah, we very thankful. But also by this chance, we also report to President that we have a good cooperation with ICHIT. So today they bring the most strong people together here. So in the future we will continue this kind of conversation, and we will try to submit some bigger grant. Yeah, and then I will report to Dr. Tu. Yeah. Okay. Then I think I saw another important thing. The person Lin Qiwan, Professor, he's kind of very kind, but I think he's also another important contributor to this conference. So I would like to invite him to give us some remark. Thank you.
I'm Professor Lin, and Jack online. I heard got the back rows. Sorry to hear that, but I'm particularly honored and great to co-organize this symposium with Professor Lin here. Our teams has been interact with the neurosurgeons teams in Taipei Medical Universities and security in the 双和医院 and with this symposium, I think the data science from the neurosurgeon images and particularly toward the dementias research will be great resources to further develop. And we co-work with Professor Tim here, not only on the data science toward the smart hospital, but also using our technologies inside the ICHIT, co-work with the team here to develop as a products toward the clinical applications. And I hope this would be the first cornerstones toward the future cooperations and successful of the cooperations. And I thank you, Professor Lin, and to give me this honors to speak on behalf of both teams. And so thank you so much, and wish for the continued success of these symposiums. And I think this is the first events of the series discussions that we initiate, and hopefully this will lay the cornerstone for our future success. Thank you so much. Looking forward to future cooperation. Thank you.
Thanks, Professor Lin. He's always very kind to support us. Then I think Jack is already ready. Yeah, Jack.
Yes. Sorry for the microphone wasn't working for a while. Due to another engagement, I'm currently in New York City right now. But I would like to congratulate all the organizer and Dr. Lin for creating this, making this conference a reality. It was just an idea a few months ago, but now we have the first Collaborative Neuroscience conference about the convergence of smart hospitals and open databases in brain research. And with the support from ICHIT, from Dr. Professor Lin and Professor Shen, Xianxian 副所长, and especially Professor Dr. Du Yongguang, and also our experts from Huashuo Asus. And we also specially invite MIT Professor Dr. Leo Anthony Sally to talk about the AI in healthcare. So I think today is going to be a very interesting conference, and I hope all of you will enjoy the conference. And I look forward to a very successful experience today. Thank you.
Okay, thank you, Jack. Okay, so then more on our first keynote speaker. The first keynote speaker, let me introduce, is Dr. Leo Chelly Anthony. And he is, actually, he is kind of a good friend of Taiwan. He visited Taiwan for several times. Previously, we have a Mimic Hackathon event in the TMU. So that will be a very success event. And Dr. Leo, he is a physician, and he is an ICU attending physician. Then he also a senior data scientist from the MIT. And the famous of his work is in charge of doing the supervise the Mimic. If you know, the Mimic is kind of a popular database. Like in Taiwan, we have NHIRDB, but it's without the electronic health record. And the Dr. Leo, he's in charge of Mimic. So basically, he's a physician and also an experienced data scientist. Then today, he will talk about how to utilize the data and to avoid the bias. So first, I will welcome the Dr. Leo. Hello,
Thank
Leo.
you very much. Good morning, Taiwan. I wish that I were there to join you in person, but hopefully soon our team will be able to visit TMU again. My name is Leo Anthony Sally. I work in the intensive care unit as a physician, but my research is at MIT. I'm a principal research scientist at the Institute for Medical Engineering and Science. And before I continue, I wanted to disclose that our group receives research funding from the National Institute of Health and several industry partners. I represent MIT Critical Data. It's a consortium whose mission is to put data and learning at the front and center of healthcare.
有啊，拍上去我都觉得有东西，我就先吃饱饱的，比较自然。
Okay. MIT Critical Data consists of healthcare practitioners, computer scientists, engineers, and social scientists who believe that data and learning are the best medicine for population health. We build communities across disciplines to derive knowledge from data routinely collected in the process of care in order to understand health and disease better in the local context. The consortium is led by our laboratory at MIT, the Laboratory for Computational Physiology. And as was mentioned earlier, we are in the business of creating electronic health record databases that are de-identified and shared with the research community. Our flagship project is called MIMIC. It's Medical Information Mart for Intensive Care. And this has been available to the research community for more than a decade now. We're proud to say that we have 40,000 users of this data set from around the world. And this has produced about 10,000 publications and conference proceedings. It is a repository of data obtained from patients admitted to all the intensive care units of Beth Israel Deaconess Medical Center. The initial data set was focused on the ICU, but over time, this has spilled over to the other parts of the hospital. So in 2020, we released MIMIC Emergency Department. We also released MIMIC Chest X-ray, which has 350,000 chest X-rays that are linked with the electronic health records. And by the end of the year, we will be releasing MIMIC Echo and MIMIC ECG, which are 100 terabytes worth of data to the research community. And then in 2016, we partnered with Philips. We were able to convince them to also open source data coming from more than 200 hospitals across the United States. And we are about to release the updated version of both data sets containing data from the period of the pandemic. But I think our biggest contribution to the research community is truly creating a collaborative ecosystem where the different groups who are analyzing the data are able to help each other. So when someone requests for access to the data sets, they sign a data use agreement, which stipulates that they share their codes and queries, they share their curation. And as people here might be familiar to the problems with secondary analysis of electronic health records, the curation is the most difficult part. That takes up 90% of our time. And in the old model, what happens is that groups start from scratch. They never share their curation, and it's a very inefficient system. And by allowing groups to be able to cross-check their codes and queries, there's a system of quality control, and there's also a more efficient system by which groups don't have to start from scratch. They reuse codes and queries. They have consistent definitions of concepts. So we think that this is our biggest contribution really to the research community. And then as also mentioned earlier, we organize datathons, which are short for data hackathons. And in these events, we bring in the university students and professors, interface them with the healthcare professionals at the hospitals and clinics. And then we bring in industry partners and we bring in the health ministry, because we think that these three stakeholders must work hand in hand to truly be able to leverage the power of data and harness artificial intelligence technology. We have hosted 39 datathons in 19 countries across 4 continents, and this has jump-started numerous international collaborations. The most important thing from these events is that they have inspired other health systems to truly make their data sets available to students and not just to limited number of investigators. So with Mimic as their inspiration, hospitals from the Netherlands, Korea, Spain, and Switzerland have made their electronic health record databases publicly available. And we are working with colleagues in Brazil, Australia, Uganda, Ghana, and Kenya to do the same and replicate this ecosystem in other parts of the world. So I think a lot of people consider 2022 as the second coming of artificial intelligence. And for reasonable events that happened last year. So in April of 2022, OpenAI announced DALL-E 2, which is a deep learning image synthesis model that generates images from text prompts, thanks to a technique called latent diffusion. And this technology became available to everyone in September. And then in July of last year, DeepMind announced that its AlphaFold AI model had predicted the shape of about 600 million proteins based on the sequenced genome. DeepMind made these predicted protein structures available in a public database hosted by the European Bioinformatics Institute at the European Molecular Biology Laboratory, allowing researchers from all over the world to access them and use the data for research related to medicine and biological science. The following month, August of 2022, Stability AI and Convis released Stable Diffusion, which arrived as an open source project complete with source code and checkpoint files. People could use Stable Diffusion locally and privately on their personal computers with enough GPU. But soon, critics complained about the software's potential to create political disinformation, non-consensual pornography, child sex abuse material, and alternative histories. Later that month, a resident from Colorado named Jason Allen won the top prize in the digital arts photography category with an AI-generated image called Theatre d'Opera Spatial. and the people flipped out. In November, Meta announced Cicero, an AI agent that beat humans at the online strategy board game Diplomacy. Diplomacy is a social game where players talk to each other. It requires extensive persuasion, cooperation, and negotiation to win. And none of the players knew that they were playing with artificial intelligence. The AI fooled the humans into thinking that the AI is a human himself or herself, and the AI was able to beat the other players. And of course, December of last year, OpenAI announced ChatGPT, a chatbot based on its GPT-3 language model. It makes probabilistic guesses about which bits of text belong together in a sequence based on a statistical model trained on billions of examples of text pulled from all over the internet. This is the first time such a powerful tool has been made available to the public through an easy-to-use web interface. 5 days after its launch, the CEO of OpenAI, Sam Altman, tweeted that ChatGPT reached over 1 million users. And in March of this year, the OpenAI announced the release of the next version, which is GPT-4, and it was embraced by the entire machine learning community all over the world. OpenAI released a technical report to accompany the announcement. And in this technical report, they acknowledge that there is a risk of large language models perpetuating the biases in society. And this is why they kept using the word safer in the technical report, because they are cognizant that indeed this could play a significant role in legitimizing biases that exist in society. And yet in that technical report, they refuse to divulge what data sets were used, what modeling architecture was employed. And the reasoning for this is that they said that the market is just, the market landscape is just so competitive that they cannot afford to release that information. And to us, this is a red flag. Since its release, GPT-3, ChatGPT have dominated the headlines and social media with applications like this. This paper got published in February of this year that demonstrated that ChatGPT was able to pass the US medical licensing examination. And the thinking, of course, is that if ChatGPT is smart enough to pass the US MLE, it will be smart enough to diagnose and give treatment recommendations. There is no denying that large language models such as ChatGPT are very powerful tools in sifting through content beyond the capabilities of experts or even groups of experts and extracting knowledge. However, we have to address the problem of data bias before we can leverage large language models and other artificial intelligence technologies. The body of knowledge that large language models train on, both medical and beyond, is dominated by content and research from well-funded institutions in high-income countries. It is not representative of most of the world. We have learned, for example, that even mechanistic models of health and disease that we have embraced during our medical training are embedded in that, and these are the content that is used to train large language models. These can all be biased. Our understanding of Alzheimer's disease, for example, is primarily based on the disease manifestation and studies on white patients in industrialized countries. This is despite this national statistics in the United States, for example, that indicate that Black Americans are overall about twice as likely to develop dementia than white individuals. And yet the description of Alzheimer's disease and its treatment in textbooks are primarily centering around white individuals with Alzheimer's disease. Ground truth in medicine is bias. The guidelines that come from professional societies are typically based on research that is performed in a handful of countries. They say that 80% of studies that are used to create guidelines come from 20% of the world's population. Surviving Sepsis campaign guidelines have been around since 2002, and when we studied where the guidelines are coming from, we found that 85 to 90% of the references that they cite are from United States and Western European countries, even though 85% of preventable deaths from sepsis actually occur in low and middle income countries. Ground truth in medicine is also constantly shifting. At 67 years old and a few months shy of 3 years after his presidency, George Washington reportedly awoke short of breath with a sore throat and soon developed a fever. Over the next 12 hours, doctors drained 40% of his blood, and then he died. The procedure was common at the time for a variety of ailments and represented the ground truth in medicine. This is a more recent example of this reality that ground truth in medicine is constantly shifting. And unfortunately, large language models do not evaluate when that shift has occurred. If you look at the 4th edition of Harrison's Principles of Internal Medicine, published in 1978, and you open up the chapter on how to treat heart attacks, you will find that these are the ground truth. These are the recommendations. Patients should be in complete bed rest for 6 weeks. They're not even allowed to use the toilet for 2 weeks. They should not be given beta blockers, and do not take them to the cath lab because of the unstable plaque. Ground truth in medicine is both biased and constantly shifting at the same time. This is a great example to demonstrate that. When his wife was pregnant in 2004, Professor Michael I. Jordan, who is a computer science professor in University of California, Berkeley, who at that time was in Canada, learned that the baby had white spots around the heart as seen in the ultrasound. And they were informed that this is associated with a 1:20 risk of Down syndrome. And the only way to confirm the diagnosis is to have an amniocentesis. But amniocentesis is not without risk. It's associated with the risk of fetal death at the odds of 1:300. Being an astute professor that he is, Professor Michael I. Jordan said, show me the evidence. Show me the study that suggested that the risk is 1:20. And he was shown this study. It was from 10 years ago. And the study came from the UK. And as I mentioned, they were in Canada at this time. And Professor Michael I. Jordan pointed out that the ultrasound that was used in 2004 had much higher resolution than the ultrasound that was used in the study. And he inferred that this could be a false positive. So they said, we're going to take our chance. We're not going to go for amniocentesis. And a few months later, they had a healthy baby girl. This shows that we need to be constantly revisiting every truths that we have embraced, because as we mentioned, the relationship between features and outcomes constantly change as practice patterns change, as technology is introduced. It turns out that artificial intelligence is no good when there are no clear rules and when reasonable people like us can disagree about the right answer. And yet many companies and startups claim that their artificial intelligence can predict the future. For example, HireVue claims that they are able to predict the future performance of job applicants by asking them to answer such questions as, is your desk messy? To infer the applicant's personalities. That sounds like horoscope to me, and yet this tool decides the fate of millions of job applicants every month. EAB Navigate in the United States claims to predict which high school students who are applying for college will drop out before finishing college. Unfortunately, the proprietary algorithms have never been subjected to rigorous evaluation for errors and bias. And it is important to emphasize that majority of investors do not care less about bias. Could healthcare be different from other fields when it comes to artificial intelligence applications? The short answer is definitely not. Of 415 published AI tools developed to combat COVID with the best resources available, not one was fit for clinical use during the pandemic. The two biggest threats to the success of health AI are data bias and embeddings of social demographic features in the data that are easily learned by computers without the knowledge of AI developers. Our group published this paper in July of last year. We reported how inaccurate readings from pulse oximeters led to clinicians prescribing less oxygen to patients of color. It demonstrates how technology designed around a certain demographic, which in the case of healthcare is typically the middle-aged white male demographic, contributes to outcome disparities. Medical devices that perform differently across populations is only one type of bias that lurks in real-world health data. And pulse oximetry is just the tip of the iceberg. In this paper that we published last month, we showed that a lot of the gadgets and medical devices that are in use in the ICU do not perform consistently with the same accuracy across different patients. So the same number might mean different depending on your body mass index, depending on the color of your skin, depending on the type of hair that you have. Here is a summary slide of the sources of data bias. This list is by no means complete. It is impossible for one laboratory, one company, one university to understand them all, especially if the team has the same blind spots. This is the reason why health data need to be analyzed by as large and as diverse a group, or preferably groups, as possible. The model where a group of experts, whether they are from MIT, Harvard, or TMU, is building algorithms is fraught with danger. When access to health data is limited to one group of investigators, there is no quality assurance of data curation. Wrong assumptions during the data curation leads to model misspecifications and flawed algorithms. What we get is AI that perpetuates and even magnifies health inequities. Our multi-billion-dollar investment in healthcare AI will be a bust. Even more concerning is the discovery that information are embedded in the data in ways that are invisible to the developers. We published this manuscript last year, and in this paper, we demonstrated that it is trivial for computers to learn the race ethnicity of the patient just based on the chest X-ray alone or other types of medical imaging modalities, even in the absence of any clinical data to accompany the images. And what's most perplexing is that we couldn't figure out what the computers are learning. It wasn't the disease distribution. We thought that maybe all the chest X-rays with pneumonia happen to belong to patients who are Black. So we trained the algorithm on only patients with pneumonia, and it could still figure out who is Black, who is white. It wasn't based on one anatomy. Maybe it was guessing it from the bones, which could give you an idea of the age of the patient, and maybe all the white patients are older than the Black patients. That wasn't the case. At one point, we were feeding the transformer random crops from different parts of the X-ray, and it was still able to tell if the X-ray belongs to a white patient or a Black patient. And that is not the only example of computers learning something that is invisible to the human eye. There has been studies that demonstrated that computers can learn the sex of the patient based on the photo of the back of the eye, the fundus photo. And ophthalmologists were shocked because they themselves are not able to tell whether a fundus photo belongs to a woman or a man. And most concerningly, what we found is computers can tell if you're rich or poor based on the chest X-ray alone. So we're finishing up a paper where we trained the computer on normal chest X-rays, so no radiologic abnormalities, and it was able to determine whether that X-ray belongs to someone who's got private insurance or who's on Medicare, Medicaid. Why do we care that computers can identify race, ethnicity, sex, or socioeconomic status from data sets? That brings me to the story of Clever Hans. Some of you might have heard about this already, but I'm going to repeat it anyway. Clever Hans is a horse, and in 1900, he was bought by a retired schoolmaster named William von Austin. William von Austin was bored out of his retirement. He started teaching the horse how to do simple calculations, addition, subtraction, multiplication. And he was astonished to discover that Clever Hans knew the correct answer every time. He took the horse on road shows around because he was so proud of his horse. But it turns out that Clever Hans wasn't even performing the calculation. What it was doing was detecting the heartbeat of William von Austin and the audience. Every time von Austin points to the correct answer, he gets excited. The people around Clever Hans get excited, and he senses it. And he knew that that's the correct answer, and he will get a treat by giving a nay. And that would happen too if computers can figure out something that is not really related to what is being predicted or optimized and use that feature. And there are so many examples of Clever Hans in the machine learning community. These two investigators trained an algorithm to distinguish wolves from huskies in photographs. But all the wolves were photographed with snow in the background, and none of the huskies had pictures of snow in their background. And not surprisingly, the computers learned right away that if they see snow, it has to be a wolf and not a husky. And again, this will happen too. If the computer can figure out if you're a man or a woman, if you're rich or poor, if you're straight or gay, they will use that information to make a decision about chemotherapy, to make a decision about who gets admitted to the intensive care unit. And this brings me to the story of MacArthur Wheeler. MacArthur Wheeler in 1995 robbed two banks in Pittsburgh in broad daylight. He wasn't wearing any mask or disguise. As a matter of fact, on his way out of the banks, he waved at the camera and smiled. That evening, he was picked up by the police, and he was so shocked when the police came to his door and arrested him. He kept mumbling, "But I wore the juice, I wore the juice." And he wasn't making any sense. It turns out that MacArthur Wheeler researched invisible ink, and he learned that invisible ink is made of lemon juice. So what he did was he rubbed lemon juice all over his face and his body, and he was convinced that he was invisible. The cops thought he was drunk or stoned. He was tested for alcohol and all sorts of drugs, but he wasn't stoned, he wasn't drunk, he was just incredibly mistaken. As data scientists, we do not know what we do not know. But like MacArthur Wheeler, a lot of us are oblivious to our ignorance when it comes to bias in the data. Consider this app that takes a photo of a mole and provides a likelihood that it is cancerous. But the algorithm was trained on images of predominantly white individuals. And worse, it could tell whether the image was taken by an expensive phone. It learned during development that a photograph that was taken by an iPhone is less likely to be a melanoma as compared to a photograph taken by an Android. And it starts using that information to make a prediction. It's easy to see why this is problematic. Misdiagnosis and medical errors will occur at scale if artificial intelligence is developed by the MacArthur Wheelers among us. And with that, I'm happy to answer any questions from the audience.
Thanks, Dr. Leo's great presentation. One of my feeling is like many news say about we need to be careful about interpretation of the data. Then you can see the most important thing is the Dr. Leo personally, he is an ICU physician. He is a long experience of the healthcare. Then even though he used a lot of machine learning and AI, try to extract the knowledge from the data, then we need to be very careful about interpretation of the data. And any question from the audience? Okay, Professor Lin.
Yes, thank you very much, Leos, for your excellent presentation. My name is Chiwan Lin. I'm from ICHIT and National Taiwan University. In ICHIT, our team also is one of your users. We use mimic data to analyze the heart and lung disease patients return from ICU to home with a risk that return to hospitals in short terms. Yeah, and thanks for your presentations again. I think you highlighted the importance of the open data sharing among the research communities, and especially toward the use of the AI with the cautions of the potential buyers. And I wonder, would you like to elaborate more within the mimic database? When we use it, how we can use the with cautious to prevent such kind of buyers, and is there any guidance or any precautions that we as researchers should look into the logical implementations and around our algorithms to avoid this kind of bias in the future? Thank you.
Yes, so I think my first recommendation is to stop using Mimic and to start using electronic health record data from Taiwan, because the models that you're going to be building using Mimic are not going to be useful for the Taiwanese patient population. And it's really important to transform words into actions, make the data sets available to the university students, to the graduate students, and allow them to work with the doctors, the nurses, the pharmacists who are working at the various hospitals and health systems in Taiwan. Because it's going to be impossible to understand how biases are encrypted in the electronic health records without working with the people who are involved in the care being provided to the patients, who are involved with the data capture. I keep saying that the most important thing that the students need to understand, even before they dive into the data, is to understand what we refer to as the social patterning of the data generation process. Because not everyone has access to quality healthcare depending on where they are. So we always say that in every country in the world, there are people who are marginalized. And it may not be based on race, ethnicity. It could be based on whether you live in rural Taiwan versus Taipei. But what we can guarantee is that the quality of care is not consistent. And there are people who have suboptimal care. And people need to understand profoundly the disparities that exist. Because if you're not careful, those disparities are going to be incorporated into your algorithms. And the reason for that is right now, the way we build models, the way we check if the model is accurate, is to see how it matches the real world data, which means that any inequities that are captured in your electronic health records will be legitimized and forever be part of the care. As where before there could be one doctor who made a wrong decision in the middle of the night, now when that becomes an algorithm, it becomes scaled, the impact of those decisions that are informed by these tools. So it is imperative that the way AI is developed, it should involve as many investigators as possible. There has to be transparency in who's analyzing the data, what sort of analysis is being performed. And it's also important that social scientists are part of the team. I wanted to point it out too that in the previous iterations of MIMIC, we only have clinical data. And we acknowledge that that's incomplete because outcomes are not just influenced by what medicines you take or what surgeries performed. Outcomes are determined by social determinants. So if we truly want to leverage artificial intelligence, we need to include in the model features that represent social determinants of health. Because if we don't do that, then again, there is a high risk that what we're going to have is AI that blesses all the imperfections of the health system. So I wanted to recap, or I wanted to summarize what I've said. I think my best advice to the audience here is that you truly start building electronic health record data sets coming from the different health systems and hospitals in Taiwan. Partner with the computer science department, the humanities department, and create this ecosystem that allows the different groups to help each other. Because at present, what we're seeing around the world is people are developing models for the sake of publication, for the sake of getting a PhD. And that's not going to solve anything. Publications are not going to change and improve patient outcomes. What we really need to do is to create a data pipeline in health systems, create a way for health systems to transform their data into machine learning ready pipeline, create the expertise, the capacity for the students to work with the nurses and the doctors and the social scientists so that you have this complete life cycle of AI that is available within each hospital. Because I'm hoping that I've convinced everyone that you cannot just buy an algorithm that was developed somewhere else and plug it into your healthcare system, because chances are you're going to be harming a lot of patients because you don't know how that algorithm is going to perform on your own patient population. These are very challenging tasks that I'm laying out on the table. But if we're going to be investing billions of dollars, we need to do this right. And also, we cannot let companies to take the driver's seat because you know their intent is not to provide equitable outcomes. Their intent is to make money. And if we let them take the steering wheel, I think we're going to be heading the wrong direction. We really need partnership between the government, industry, the universities, and the hospitals to make this work. Anything else is probably going to waste our talent, it's probably going to waste the technology, it's going to waste our money.
Okay, thank you. I think Jack, you have a question. Okay. Jack.
Yeah.
Please.
Yes. I was. Leo pretty much have answered my question, but I was just want to add that the samples in the guidelines, the references that the guidelines were based on are biased, and actually most of the clinical trials are biased as well. I think Leo also talked about that. So that's another layer of probably even worse problem because all the drugs, the new therapeutic technology that we're using right now are mostly based on not completely unbiased evaluation, even with multi-nation, multi-center trials. So I mean, the whole medical science, are based on a biased sample to begin with. It's mostly a sample of convenience or a sample of, within the budget, feasibility, and not a sample of representativeness or unbiased. So I'm just wondering, I mean, how can we fix this whole ecosystem? It's not just AI got affected, right? Because now AI are based on the data are based on the trials, and trials are based on these biased or incomplete, non-representative samples. So if we are trying to fix the ecosystem, where it would be a good starting point? Because if we start at AI, it's kind of like it's already on top of other problems, right? Is there a more fundamental step that we can take to actually start to try to improve this problem?
Yes, so I credit AI for making this a sexy problem because as Jack, as you know, this problem has existed forever. Historically, the medical knowledge system is controlled by a small exclusive group of people who decide what should be considered medical knowledge and what should not be considered medical knowledge. I think the first step is to diversify that group of people, make it a much larger table of deciding how do you create and validate medical knowledge. We have to have more representation from countries who are disproportionately burdened by diseases and disasters. And that's not so easy to do. But here, at least in the United States, we're seeing very bold strokes from the National Institute of Health, from the Food and Drug Administration. There is strong agenda to overhaul the system. And what we're hoping, and I'm actually optimistic that we're finally going to see some radical changes in really improving the way we create knowledge, because everything boils down to the knowledge system. And as we know, there is such an imbalance in who holds power in this knowledge system. And I think that we need a critical mass to fully own up to the problem, that we are part of the problem. And somehow we need to bring in more perspectives, because the research agenda is definitely driven by who sits at the table. And if that table is primarily consisting of white male professors from the top universities in rich countries, then nothing is going to work. And I may sound pessimistic during my presentation, but actually I'm very optimistic. The fact that I'm able to talk to people from around the world, talking to them about the problem and getting them excited in finding solutions, I think that the stars are aligning, that finally there will be more representation at the table. Here at the United States, the National Institute of Health said that we're no longer going to evaluate proposals based on where it's coming from. We're going to be evaluating the proposals on the merit of the proposal. We don't care if it came from MIT or a community college. That's not going to be part of the evaluation anymore. There's also a lot of funding that is being directed to minority serving institutions. So it's no longer being given to Harvard and MIT. You can only partake of this funding if you partner up with the less traditional research institutions who may not have the same quote unquote expertise, but they have the perspectives to truly solve the problem. And we keep saying that you could have a group of experts who don't understand the problem, similar to all the blind men trying to look at the elephant, where they're not seeing the big picture. They're only seeing one part of the elephant. So it's a bit of a high level suggestion of what we need to do. but there are definitely some policy changes that are happening, and I'm hoping that these policy changes would spill over to other countries. In the United States, there's an initiative now that health systems will be reimbursed depending on whether there is a lot of health equity or inequity in their systems. So payments are now going to be tied, looking at disparities in outcomes. So there is now a financial incentive to make sure that one group is not being left behind when it comes to clinical outcomes. So I think these are innovations that will truly revolutionize healthcare delivery. The technology advances need to be accompanied by innovations in the incentive structure, because you cannot solve the problems of healthcare with technology alone. I think everyone knows that by this time. We are not the first generation of technologies who have tried to improve the way we deliver care, and every generation after another, they failed. Schools of public health were established in the 60s, 70s to reduce health disparities. And where are we now, 50 years later? We have exactly the same health disparities. So the good thing is we are now more open to bringing in people who don't think the same as we do. There are more and more collaborations between computer scientists and medical school, nursing school, social scientists, to try to come up with a better solution that has definitely provided with different perspectives. So as you mentioned, AI by itself is not going to fix the problem. It has to be a multi-pronged strategy to not just fix the data, but fix society itself. Because you cannot fix the data thinking that society will somehow get better. You need to do both at the same time.
Yeah, and yes, and apparently real world data, the more use of the real world data from sources like Mimic will also help the biased or representative sample issue. So I think that's actually a very good place to start. Thank you.
And Dr. Chen, you have a question?
Very short questions for Dr. Liao. We're especially interested in the wearable devices since we've been, now we are carrying the research grant from the Ministry of Technology with the the biggest semiconductor packaging company, Advanced Electronics. Also, we are doing the research on the patch stickers, which already passed the FDA safety clearance and the TFDA. But from the Mimic 3, we've been participate with Dr. Jack Lee 6 years ago. What do you think as intensive care unit's physician about these patch stickers application in the future, especially after pandemics? Thank you.
Yeah, no, I'm a bit skeptical about the wearables because most of the wearables are designed around fit male athletes. And I wonder whether these wearables will have the same accuracy among the patients that we are prescribing them for. And these are typically elderly patients who are who may not be similar in terms of their body mass index to the test subjects. So I think my advice for people who are creating technology is that they design this around the patients who would benefit the most from that technology. And unfortunately, those are not the college students that you recruit when you're designing these devices and medical equipment. They need to be designed with the people who are most likely to benefit from that technology in mind from the very start. What happens now is that the product is developed and designed, and then as an afterthought, they start thinking, hey, wait a minute, is this gonna work for our elderly patient? And that should not be the case. From the very beginning of the design thinking phase, you truly need to involve and engage the patients that are most burdened by chronic diseases. Because if you don't do that, then chances are it's not going to be performing well on those patients, and you might even be harming. But I truly think that wearables are going to play a significant role, especially during the pandemic. I think there's going to be a shift to hospitals as places for the very sick. There will be more and more patients who will be cared for at home, which is safer because you don't congregate people with infections in one roof. But to be able to do that successfully, I think the design of the hospital at home, the design of the future ICU has to be centered around the patients and not healthy subjects that we are using as test subjects for this technology. So it will require a changing of the way we create innovations, but we need this. Again, I just wanted to say that, and I give this advice to startups and entrepreneurs, like don't start to think that you're the first group of people who have come up with this idea. A lot of devices and gadgets have been thought of in previous years and they failed. What you need to ask yourself is, why did they fail? Because trying to just reinvent the flat tire is a waste of talent. It's an opportunity cost. It's a waste of money. And I keep saying that we need to have a resource for people who want to innovate, a resource where they could review the innovations that have not worked in the past. And unfortunately, right now, that doesn't exist. There are a few post-mortem of failed startups, but for the most part, we don't really learn about why the tens and thousands of startups in health tech have failed in the past. And I think we need to learn from previous failures so that we will be able to do things right. And again, my main suggestion is, when you're designing, you need to bring in more people as part of the design thinking team. There has to be more citizen science approach, more involvement of patients. Interviewing one patient for 2 hours is not enough to be able to design solutions for them. I keep telling that if you want to build a product for diabetics, there has to be people with diabetics who are part of your design team, because you will not understand the problem unless you're living that problem in the first place. But for the most part, people who are in the entrepreneurship communities, they're not very inclusive either. Here in the United States, they're mostly coming from the top universities. They think they understand the problem because they've read the books. Some of them have written the books. But to me, that is an example of what I call AI, arrogance and ignorance. You think you know the problem, and in fact, you're like MacArthur Wheeler. You don't know what you don't know. And somehow we need to change the way we're teaching students in business schools. And there has to be also a change in the demographics of the people who are innovating in healthcare, because repeating the same mistakes from previous years and expecting a different results is the definition of insanity. You cannot have the same strategy. You cannot fix the problem with the same people who contributed to the problem in the first place. Somehow you need to bring in people who think very different from you, because chances are that's when you see the magic. Like, we come up with the best ideas when we're speaking with people outside our fields who don't work in the intensive care unit, and somehow we come up with some designs of solutions in the ICU. So make the teams even more diverse, reach out to people who are living the problems of diseases and injuries, because their input is going to be crucial to have the optimal design of the solutions that will truly improve the way we deliver care.
There's an online question for Leo. How do you think the OpenAI provide the business version for healthcare? It said that the database and the operation is out of public, and the healthcare data won't leave the hospital. Also, the GPT-4 could assist medical image diagnostic report. How do you think about that? Thanks.
We are concerned. We are concerned about the partnership of Epic and Microsoft and OpenAI. I don't know why we keep calling OpenAI OpenAI, because there's nothing open about OpenAI now. And as I mentioned earlier, there has to be transparency on who is analyzing the data, what are they analyzing it for. My concern is that they're gonna be using this to promote more health products, and come up with ways to make money off the patients who are already bleeding because of healthcare expenditure. There are some, so for example, for Mimic, we just released an announcement that you cannot upload Mimic notes into OpenAI, because you sign a data use agreement that the data can only be, cannot be shared with people who are not credentialed. And as soon as you upload the clinical notes into OpenAI, you know that they're gonna use that for all sorts of profit-generating reasons and not really to improve healthcare. Our group is working with Hugging Face, which is at present still open source. It's also a large language model that is trained on billions of parameters from the internet. And we have an agreement with them that all the models are gonna be developed in an internal server that is not going to be available outside of our group. So I think it's very important that you have control of who is doing what to your data. And that there has to be more capacity within the health systems. You cannot outsource this to a third-party vendor, because I personally do not trust third-party vendors with regard to their true incentives in creating these models. There's a lot of discussion about Palantir and the NHS, and there's a lot of skepticism and concerns among the patients there and healthcare practitioners, because this is done all within proprietary environment. And I think that that is perfect recipe for disaster if this is done in a proprietary manner. And I think we really should be pushing for the development of AI to be as open and as transparent as possible, because these tools are so powerful. And I think that if we don't take the driver's seat, we will be swept by this tsunami, and we will not be able to fully harness their value. And this means that countries and professional societies should really invest in capacity building, in making sure that the future clinicians, the future computer scientists are all up to speed when it comes to what do they need to learn, so that they could harness the data that is being generated from routine care, to be able to harness the power of TPUs and transformers. because without building the capacity, I can't foresee a bright future for AI. If the ability to harness AI is in the hands of a few people, that is your definition of colonialism. What's going to happen is the rest of the world will probably be taken advantage of if they don't understand how to use AI. So there has to be more investment from the government, from universities, to truly incorporate data science in educational curriculum, in training curriculum, and start early. Like we have a grant where we're teaching data science to high school students. And I think you have to go earlier, because if you don't understand data science, someone is going to take advantage of you. Someone is going to misinform you and convince you of false findings. And unless you have the critical eye to call them out, like, hey, there are a lot of confounding here that you did not include, there's data leakage in your models, then chances are you will be abused, you will be taken advantage of. So I think it's imperative for all of us to make sure that our children and grandchildren understand data science and artificial intelligence. Otherwise, they will be taken advantage of.
Thanks, Leo. Yeah, I think Leo just reiterated the important issue that AI should be regulation, and healthcare is very important. I mean, the AI cannot be beyond our imagination and creativity, because we are dealing with the human being. And let's back to the one thing from your talk is about the inconsistency of the oximeter posimetry in ICU. So this remind me one thing is a few years ago, Jack and me, we talk about the data inconsistency about the laboratory data. Can you, because in Taiwan or ourselves, we are also creating our database. So either the accuracy or the consistency of the data is kind of important. Can you elaborate a little bit more why you come up with that topic? You just randomly choose, you think the oximeter probably there were some inconsistency, or the mimic or your staff team, you already have some systemic work to analyze the data flow to make sure.
Yeah, no, I mean, this is not new. As early as the 1990s, there already has been publications that say that pulse oximeters don't perform as well for individuals of color. And it became, I think, more important during COVID. I am one of those people who bought a pulse oximeter so I could monitor myself, not knowing that it's probably overestimating the amount of oxygen. So the paper that I mentioned earlier showed nicely that as clinicians, we trust this technology, and we were caught off guard to discover that we were giving not enough oxygen to patients of color. And then when we started looking more and more, are there other types of technology that are performing differently across populations? We were able to identify so many. Some of the more common examples would be the ECG. So ECGs, as you know, for large-breasted women, for morbidly obese individuals, would have very little amplitude. So the question is, how many ischemias did we miss? How many conduction abnormalities did we miss because the amplitude is so small? And then we started looking at EEG, and it turns out that EEG leads don't stick to certain types of hair. How many seizures did we misdiagnose, or did we underdiagnose or overdiagnose because of the artifact that is produced by an EEG lead that was not designed to adhere in the same manner across different types of hair? So I think we've become more aware now that the technology that we've embraced may not be performing similarly, and that becomes problematic. So one of our projects now is to simulate what is the impact of these technologies on downstream prediction tasks or optimization tasks. Can we truly optimize mechanical ventilator settings if we couldn't trust pulse oximetry readings that are used as features? So we've been trying to nudge the machine learning community to address these more fundamental issues rather than just focusing on coming up with a better transformer that will take in much larger gobs of data. I don't think that is what we need right now. We need more people to think about what are the implications of data bias on downstream prediction tasks, and what would be the impact when we have this algorithmic bias that is baked into the decision support tools that we're implementing. And at present, there are very few groups who are doing this type of work. And we need more to think about, because we have to be more creative. We cannot predict the outcomes in this world where there is such inequities in the delivery of care. Somehow, we have to predict an outcome if the world were fair. And then we have to accompany that with interventions to make more equitable implementation of interventions. And these are not so simple. And most of the time, PhD students don't want to work on these projects because they're so complex. To be able to solve these problems, you need groups of PhD students from different departments working together. And right now, there is no incentive to do that. Our task for PhD students is to come up with 3 projects that they're able to publish, and that's it, they get their PhD. And I think we need to change that, because all we have is this tsunami of PhD papers that don't mean anything. That's not going to transform healthcare. So there needs to be a lot of innovation in the way we do things. That's where we need innovations for, not necessarily on the technology itself. There has to be more innovations in designing a whole system, in redesigning the incentive structure for academic promotion, for allowing students to graduate. And I think that's where we have to be more creative. And that's where we need to invest our time fleshing out, and not just designing and redesigning and re-engineering technology.
Yeah, I think you mentioned one point is evaluation of the data itself is very important, not just creating something, but we don't know the quality. Yeah, because by the project we are doing, we try to collect the EEG data. Currently, we have 200 patients data set. Then we use the different, like using the lead, also using the cap. But when we analyze data, we are thinking about probably the different, like the type of person or the condition of the patient probably can be a bias. So I think in the future we would like to have, because we try to create our own mimic-like thing in Taiwan. So you just mentioned that probably we should build up some certainty of data guideline. Then we need to fulfill some evaluation and the quality check. Then we can ensure our data is won't be go wrong. Yeah. Is still any question from the audience?
There's a question on the chat box from Harry. What is the role of the human element? Are humans still needed? Yes, of course. I don't think what we need to design is a universe where there is the humans are working harmoniously with the machines. I think that's what we need to design. It shouldn't be just the design of AI, but the design of AI that is working hand in hand with humans. And the human feedback is always going to be required. You probably heard of reinforcement learning with human feedback that is being used with large language models. And I think that that's going to stay, that humans are always going to be in the loop. But it's very important who those humans are. One of our projects right now is trying to understand who are the humans who are providing feedback to large language models. How representative are these humans? What biases do these humans have? But I don't think that we will be replaced. One question that keeps getting asked is that, are we gonna get dumber because of artificial intelligence? And my answer to that question is, if you are dumb, you're gonna get dumber. But if you're smart, you're gonna be more productive, you're gonna be more creative if you're gonna be using artificial intelligence. So I think, again, we need to reimagine the world. I keep saying that every organization should have generative AI in their 5-year plan. Medical schools, nursing schools need to start thinking of how do we educate the next generation of nurses and doctors who are able to use generative AI. For researchers, how do you incorporate generative AI as part of research protocols and research methodologies? Because if you don't plan that, you will be left behind. There are people who are able to do this well, and those are the people who will rule the world. So start thinking of, again, how should AI be part of the medical curriculum, nursing curriculum, computer science curriculum? And what we have been trying to do really is to promote interdisciplinary curriculum. So in the same classroom, you have doctors, nurses, computer scientists, engineers. They're able to learn from each other. They're able to learn together. That has to be the design of the education of the future. So we need more creative ideas. We would like to recruit more people to allow us to redesign the world, because I think it will need a lot of re-engineering so that we could truly harness the power of this technology.
Okay, thanks, Dr. Leo. I think the final question. Yeah, sure.
Hello, doctor. Thank you very much for your presentation. I particularly working with Mimic Waveform database, and I also working on a development of device for elderly to monitor their blood pressure more easily and more convenient for their use. So my question is that if we consider developing some device, right, and maybe Mimic Waveform database is something that is only available, I'm just curious about your opinion. So is it better to use only like what we have available right now, or should we, if we consider developing a device from the scratch, is it better to firstly to collect the database from the representative population? Because sometimes there is a problem, but there is no time, right, to collect the database. It's an extra time, taking everything into consideration, IRB, recruiting the participants, but sometimes, yeah, we just don't have time. We want to solve the problem. So what do you think is the optimal way to solve this situation?
I mean, personally, I think it's a waste of time not to start building your data sets. I think you need to start demanding from the health systems there in Taiwan that they need to invest in data sets like Mimic to be available for students in Taiwan. Because as I keep hammering, the models that you build on Mimic will not be applicable to the elderly Taiwanese population. And I think it's good to learn from Mimic, but I would say invest more of your time in truly building models based on data of the patient that you want to design solutions for. And I know it's hard. and this is really a call to the leadership at universities, leadership at the health ministry, that this cannot go on. Like, it will not magically happen. We know how hard it is. Like, we've been in this space. We're willing to share all our toolkits, all the lessons learned. So that's what we do when we travel around the world, is we assist organizations. And what we have also done is to create regional hubs. So what we've done, for example, in South America, is we connected them and we encouraged them to come up with open source tools, come up with some GitHubs and notebooks on how to create these data sets. Because people are, I mean, it's understandable that people are going to be trying to take the path of least resistance, and the path of least resistance is using a data set that's already available. But what makes life more exciting is to truly challenge yourself, take on moonshot projects. And as I mentioned earlier, PhD students should be working together to create the data sets. And we need to incentivize them. We need to say that you're only going to graduate if you're able to create the data sets that future PhD students will be able to benefit from. But we need help in convincing university leaders that this should be the way to move forward. And we cannot continue with the status quo, because the status quo is very expensive, it's very inefficient, it's very ineffective. And if we truly want to make a difference, it's going to be much harder, but it's going to be worth it.
Thank you so much.
Okay, thanks, Dr. Leo, very much. I think Dr. Leo is not just bring us hype. They just not tell you some successful stories, then make you just feel excited about it. But he to give us a lot of experience about that you need to avoid some limitation about the data set. So I think that is a very valuable information, and only the truly people who work with the healthcare experience, they also know the IT experience, then they can give you the advice. Then just like the title of this conference say that, and Dr. Leo keeps saying that we need to have some more collaborative, because not only one can understand the whole thing. So we need to join all the smart people together. Then I'm looking forward to, in the future we can invite, because right now the COVID, we can travel, then we can invite you to come to Taiwan. Then because this is a series of smart hospital project, then we are doing some mimic work too. Then after we have some result, and then probably we can invite you again to give us some advice. Okay, so then we will close, and we have applause for the Dr. Leo. Thank you.
Bye, thank you.
Thank you. 好，那我们接下来we will move to the session. But before that, how about we take a group photo? Yeah, please, everyone. Yeah, we invite everyone come forward. We take a group photo, please. Please, everyone come inside, in front.
上。好，我们先拍好了 ，OK。我们可以先拍一个，然后再等一下再停，等 Jack 这样。
我在线上啊，嗯。
最后我们现在已经在拍照，你有在荧幕前面 ，OK， 没问题 ，OK， 好，比个赞，老师 ，OK， 好，谢谢。好，谢谢。好。再来就是 coffee break， 应该是休息多久
？10 minutes. We will have 10 minutes coffee break. So please go back in 10:40.
to be here to talk about our Alzheimer's prevention. My name is Su Fang Wen from Industrial Technology Research Institute. I have nothing to disclose. In today's presentation, firstly, I will introduce a natural ingredient for the prevention of Alzheimer's disease. Secondly, talk about a POC study of a natural ingredient in MCI patients. And finally, to go through a population-based prediction for subjective cognitive decline. As you might know, global prevalence of dementia is increasing over the past decades. The number is estimated to be triple from 2015 to 2050. Along with this, the annual cost of dementia is growing with $2.8 trillion forecasted by 2030. Dementia is one of the main causes of disability and dependency, with 60 to 70% of cases. Alzheimer's disease is the most common form of dementia. However, across the AD continuum, a majority of the population are in preclinical stage, around 75%. Therefore, interventions starting at normal cognitive and preclinical stage would be beneficial to prevent AD continuum. Indeed, in recent years, AD therapeutics have been shifted to earlier disease stage, mainly focusing on disease mechanisms, helping to keep symptom-free for as long as possible, as well as precision medicine involving smaller group of patients with shared characteristics. Several prevention trials have been conducted in monoclonal antibody against amyloid beta in phase 3 clinical trials, enrolling cognitive normal participants. So next, I will introduce a natural ingredient for the prevention of Alzheimer's disease in animal models and its mechanisms underlying the pathogenesis of Alzheimer's disease. Since 2017, we have been devoted to develop natural products for mental health and neurological disorders. And one of the patent ingredients denoted as Buku M, asserted improvement of cognitive impairment in animal models. In the triple transgenic mouse model of Alzheimer's disease, Buku M improved learning and memory at 3 months by Morris Watermaze and t-test. In red cortical neurons, Buku M ameliorate amyloid beta-induced neurotoxicity in terms of cell survival and neural growth. By immunofluorescence and immunoblotting analysis, Buku M reduced axonal damage and TDP-43 pathology, as well as neurofilament downregulation. Of note, Buku M reserve pre- and post-synaptic protein levels in neurons by immunofluorescence and immunoblotting. Interesting, we found Buguan also promoted neurogenesis as evidenced by double coating and BDNF signaling. So overall, Buguan preserved axonal and synaptic protein functions that was ablated by amyloid beta for 72 hours exposure. Further, to test the effects of Bugu-M in humans, we collaborated with National Taiwan University, Yunlin branch, to conduct a POC study in patients with MCI. This is an intervention study enrolling estimately 30 participants. We collect blood samples after Bugu-M oral administration 12 weeks by analysis of ApoE genotyping and biomarkers. In particular, we look at two intermediate filament, GFAP and neurofilament light, for their emerging roles in pre-symptomatic and symptomatic AD. Here are the preliminary results for baseline characteristics of the participants and ApoE genotyping. Similar to ADNI database, around 40% of the participants are ApoE epsilon 4 carriers in our study. Alongside this, we analyzed the plasma biomarkers associated with Alzheimer's disease. As you can see here, the alteration of GFAP, YKL40, and TDP43 are reduced among the two groups. However, the neurofilament, neurogranin, and alpha-synuclein are different between the epsilon 4 positive and negative groups. Next, to expand the usefulness of the natural gradient in AD continuum, we attempt to identify the population with preclinical states of AD by population-based data. As per the data from BRFSS in the United States, nearly 1 in 10 people aged 45 and older report having confusion or memory loss that is happening more often or is getting worse. Most importantly, around 50 disrupt everyday tasks and or interfere with work or social activities. And around 40% give up day-to-day activities. In consideration of biological and behavioral data, we first selected shared data for its longitudinal, multidisciplinary, and multinational data set, which provides physical and psychological health biomarkers, including ApoE and some inflammatory factors, economic status, and social support. So by collecting variables associated with subjective cognitive decline from the literatures and clinical trials, by inputting some of the data from SHARE, including physical, psychological health, economic status, and social support, we initially built a SCD risk prediction model. However, this model is not perfect. So at this moment, we try to optimize and validate this model by inputting more different data. For example, biomarker to stratify 3 groups, such as normal, pre-SCD, and SCD. So in summary, today's presentation, we show you a natural ingredient for the prevention of Alzheimer's disease in animal model and its effects on AD biomarkers in terms of neuroinflammation, neurodegeneration, and synaptic function in MCI patients. In the long run, it is needed to find SCD risk population. So with that, I would like to thank all our collaborators and our colleagues for their contributions on this work. Special thanks to the participants in clinical research. I think that's it. Thank you.
We thanks Dr. Wen's wonderful talk. And now his talk is open for discussion. Any comments or questions? Okay, I can share my experience on the dementia clinical study. First, the most successful non-pharmacological intervention is finger study. Yeah, I asked the PI why your study can be successful and the drug fails. And he answered me, there are some tricky. One is you have to select the correct participants. Indicates we have to choose the high-risk patients. So your strategy is very good. And actually, they consider some chronic disease like hypertension, diabetes, and the cardiovascular risk factor into the evaluation to select the participants. Second, he said the intensity is very important. So they integrate 5 modes of interventions, including diet, exercise, cognitive training, and social engagement. And the trial lasts for 2 years, and they can find the positive result. So I think the intensity is also very important for a successful trial. And the others, as you know, the current, till now, the nutrient or nutrient supplement in a lot of clinical trial also failed. But recently I read a paper, they recruited a cohort of retired people. One group, they have some supplement, the other without, and they find at least 5 years, and they can find the instance of dementias are different. So I think in the future, the diet or supplement maybe can contribute to the dementia, especially Alzheimer's disease prevention. Okay.
Yeah, thank you, Dr. Hu. That's what we think. Because the preclinical of AD is, I think it lasts for like 10 to 20 years before the onset of Alzheimer's disease. So it's better to define the subjective cognitive decline population from some objective, but not subjective parameter. So that's why we are working on to stratify some pre-SCD or SCD population from the multinational or multidisciplinary data from the share.
Okay, thank you. I look forward the strategy is successful.
Yeah,
okay.
Thank you.
Any other questions or comments? Okay.
Dr. Wen, currently we are using external data sets for the investigations of the SCI, and I'm wondering, is this part, how we can proceed with the data from Taiwan, especially from your institutes that with possible populations or investigations going on in this area. Thank you.
Okay, it's maybe later we can share our dementia data set in our hospital. It's a very long-term collection of data, including the cognitive test, blood biomarker, and also image. Also the record of their medical records. Maybe we can find some indicator to make to help us to find the SCD population as a risk for the dementia development.
Yeah, that's great. Thank you.
Okay, thank you. Okay.
Okay, thanks.
Thank you, Dr.
Later
Wen.
we.
Yes, I thanks Dr. Wen again.
So we move to the next, because later we will have panel, so we will still have time to discuss, but we will finish the next section.
Introduce Dr. Lin. So next will be Dr. Lin. We will know Dr. Lin is an expert in robotic and AI surgery in neuroscience. And also in these years, he focused on a smart hospital AI data integration to facilitate the rehabilitation of brain injury process. So it's very great to have this chance to listen to his sharing about this year's research in this area. Let's welcome Dr. Lin Mingjing.
Thanks, Dr. Stran's introduction. Okay, my name is Mingjing Lin, and as you know, I'm fully appointed with as a neurosurgeon in Shanghai Hospital. But before that, I spent more than 20 years doing the medical informatics work. So, what my expert is, or what my more familiar is doing the IT thing. And today I want to share a little bit some of our result we're doing regarding the smart hospital, and we are focusing on create a consciousness database. And this myself. And I really like the Steve Jobs quote. He say, "You cannot reconnect the dot looking forward. You only can connect them looking backward." That's why my feeling is because there are so many people that are trying to doing the same thing. But like I met Professor Lin, then we talk, then we think probably we can have this kind of conference to have all the people join together. So yeah, that's the goal of this conference. So I think all of you already have some talk about Mimic. Then just like I say, like we invited Dr. Leo to come to Taiwan. Then the Professor Jack Lee, he encouraged me, why not you can do your own Mimic version from Shanghai Hospital. That's the whole story beginning. Then on top of Mimic, because I'm neurosurgeon, so we think about the EEG probably is something we can add on value. So that time, Professor Guobo Zhao, he has a device for 2-lead EEG. So we start to do our preliminary research in Shanghai Hospital. We put on the continuous EEG on patient, and we start to create our own EEG database. And you know, the PhysioNet is another great data mart. It actually is kind of more top level of the Mimic. Mimic is also part of PhysioNet. So if you want to look at more complex data like the waveform EEG or EKG, you can go to check the PhysioNet. It's also developed by under the a group of professors from MIT. Okay, so let's start talking about what we do in the past 3 years about our own data mart from our ICU. So in our ICU, we have 20 beds in our NCU. So each bedside, we have a Philips monitor MP50. Then we have a wireless EEG and the EKG. And so this is the database design. We link our EHR market and also link the EEG data. So here is the device picture. You can see this is made by Professor Guobo Zhao. They have the Bluetooth capability. Then you use the Bluetooth to connect to mobile phone. So it's kind of easy that you can just connect to the patient and then send back the data to the computer. So compared to the traditional HP monitor, which is kind of closed system, because even we pay the money, but we still cannot get exactly the waveform. So for the researcher that this kind of barrier is kind of problem. So at that time, we do some proof of concept to see whether we can put this kind of device on patient. And this is our architecture. So during we totally run almost about 6 months, and it runs quite well. Then after the COVID, so we stop a little bit. Then you can see we almost collect 400 patients' data, including the ICHIT, some SDH, SH, and some infarction and stroke patients. Most patients are in the neuro ICU. So we have a kind of the patient. We collect not only the EEG, we also collect their EKG. So as you know that there are some research talk about the heart rate variability. So one of my graduate students just graduated that her research found out they have some abnormal laboratory data is related to HRV. So you can see even though in the morning the Dr. Leo said he won't believe the AIoT, but this is a case that we can use some AIoT continuous monitoring. They can give us a hint that, okay, this patient may be something wrong. We need to get the blood test. So this is some preliminary about that. Then we have a software team. This is regarding the data quality, because we need to know whether they are the connection or they are firmly attached to the patient. So we also develop our own real data monitor to ensure the data is input correctly. So we can do the HRV, EEG analysis, and so on. Okay, so at the same time, this project, we also got another funding. So we also cooperate with Ho Chi Minh University, their affiliate hospital called Choré Hospital. So in Choré, in Vienna, they still have a lot of brain trauma patients, because even in Vienna, they have the law to wear the helmet, but they still have a lot of head injury. So at that time, we also bring our device to Vienna, and so that's another data source that if we want to do the external validation that the Vietnam, we have a cooperation with them. Okay. So that's some preliminary based on the idea or mimic we did, then we do. Then here, yeah, this slide from Dr. Hu Chaolong. This is another resource from our dementia center. I think Dr. Hu already showing you that we have more than 3,500 patients, including all the KIC, neurological exam, and the laboratory data. So later we can discuss how we can utilize this data for cooperation. So I think later, besides the EEG, we also have a great database regarding the Alzheimer. Okay, so that's the background about what we are doing the smart hospital. Then back to the neurosurgery, there's one important thing is we really care about the patient's outcome. Then you can see this is the famous guy, Michael Schumacher, which have the head injury. And he has been the coma for comatose for 7 years. Then they spend tons of money to take care of him. So that's the problem daily we face in the hospital. Like the patient's family will ask me how long the patient will recover and how well and how much. So right now in our daily practice, there still is a very hard question is, do we need to continue to save his life? So that's the top, very hard question for us. So under, in Taipei, Shanghai's TMU, we have an architecture called Taipei Neuroscience Institute. You can see it's led by Professor Du Yongguang. He's a great leadership. So we can have a very good cooperation between the neurosurgery and the neurology department and so on. Then last year we submitted a project called iGuardian. Then we tried to collect the patient's data set to predict the brain injury. So we can see we have a good combination. We have Jack Lee, me, myself. We have Chen Long Shanghai Hospital here. We also invite the NTU and the Chorei and the Tzu Hospital. And we also cooperate with Asus. So you can see we have a good liaison that we have a lot of people grouped together. Then we have the NTU and the Hualien Tzu IRB is going on. So I think this is a great framework that I also want to utilize this opportunity that to say that we already have some protocol to collect the data. So in the future, we hope we can extend this idea into other institutions more. Okay. So then this is some, last year I read about a paper published on Nature Neurology. Then there's a term called neuroprognostication. I'm kind of excited because it's exactly the same what we are trying to do. The idea is they say that, yeah, how to predict the brain injury in the objective way is kind of a problem. We think we need to build up the algorithm. So simply saying is that we need because we have a monitor for measuring blood pressure. We have a monitor for measuring blood sugar, but we just don't have a machine can monitor or measuring the brain's the severity. So we don't know how to say, because I talked to many clinical champions. They say those people are OCA. They receive the CPR. They go through the hypothermia for 1 month. But in the end, how can we predict the 6 months later the patient will recover or not? But we just don't know. So this paper, they address that it is very important that we need a model to give the physician to help to solve this problem. So they summary that there is a different multimodality of data can help to solve this problem. But actually, I think each of these has been published on some paper. So including some image like the structural MRI, DTI, and some biomarker, EEG, stimulation-based EEG, or PET, or the single photon. So you can see that in the science, in the clinical world, they try to use the different modality to decipher the brain's function. So we are luckily, we try to do our best. So in this project, the patient, we will do the image, and we also do the stimulation EEG on each of patient. Try to collect the different information of the patient. So here is the illustrate, and I think the first one, if you are interested, you can go to published from Columbia's group. They use audio voice command to collect the EEG data. So here's some more detail about the stimulation-based EEG. So basically, they just ask patient to close eye, then they will, a voice command say open hand, close hand, open hand, close hand, then for 10 minutes. Then they will resting for another 10 seconds. Then they will repeat this. So you can see that in the past, we use a command base to evaluate patients. I say, oh, please raise your hand, so that would be a problem. The extremity case is like a lock-in syndrome patient. Actually, they have conscious, but they just cannot move their hand. So in this case, even the patient, they imagine they are moving their hand, then they will have the brain activity. So that's the pro of the idea. So yeah, so there's some detail I won't talk about. So in this study, they successfully differentiate the healthy and they call CMD and the vegetative patient. So in the past, the vegetative patient or the cognition motor dissociation patient, if you ask them to raise your hand, they cannot differentiate by traditional command-based evaluation. But with the EEG, you can see there's some brain activity differences. So that's the idea. So in this project, under the IRB, all the patients, we will go in the stimulation-based EEG protocol. So daily, we will survey all our patients. If they fulfill the inclusion criteria, we will ask the patient's family to collect the data. So we have 3 persons. And this is the device we use. The device we use is the 32-channel EEG, and they can use the cap or the lead. So it's depend on the patient's condition. If the patient don't have the surgery, we will just use the cap. It's much easy. Then if they have operation, then we will use the lead. So you can see this is our device we use. So we record the waveform. And the research protocol we use the E-Prime software to developer. So it's kind of easy. So we are planning, if we going to collect data from NTU and the CG, we just send out the computer and the staff with some training, they can do that. Okay, so yeah. And our gold standard is we use the glaucoma recovery scale. So compared to the GCS, they collect more information. Okay, this is some real picture of how we did, yeah. So yeah, there's some exciting number. Since we start from late that year, then we almost reached 200 patients. Then you can see we quite well. I think this is some disease breakdown. So the TBI, ICH, and infarction and brain tumor, vascular dementia. So you can see the infection patient. We have the 70 patient, and about 34 is responsive, and the 14 are non-responsive. So you can see this is a very useful database from our local side. So those patients, we have the image and also have the EEG data. And we are trying to add in more data. Then we are, hopefully, we will collect the CSF and the blood sample after the IRB amended this month. Okay, so you can see the current data we see. So right now we collect data in Shanghai Hospital. So the Taida and the Tsuji is going on. Okay. Yeah. Then another two-side interest is we also cooperate with the Wanbang Hospital HBO Center because the Gaoyayang hypoxic oxygen, because there are some head injury patients, they will receive the HBO intervention. We know that most study we cannot do the intervention, but in the Wanbang Hospital HBO Center, we will collect 3 times of the EEG and some evaluation with the HBO intervention. And Xiaozhongzhen is a nursing home care, so they have more patients with comatose. So one of our collaborators, Professor Lanting, they are interested about comatose patients. So you can see under this smart hospital project, we have a lot of cooperation. We have opportunity to collect the data. Okay, these are some biometrics. Okay, so I want to use this. I think the overall goal for what we are doing for digital health is we have to remember we are not just create a smart dashboard for people to read. I think the most important thing is we need to let computer to understand and to help us. So that's some quote by my advisor. I think that is the final goal is we want to use computer can understand the data and to help us to take care of patient. Okay, so we will have more this kind of opportunity going in the future. Thanks.
Dr. Lin for sharing so excellent and integrated system to help the brain injury and neuron surgery after surgery rehabilitation system. And so we maybe we open 1 or 2 questions for this topic. Please.
Hello, Dr. Lin. I very enjoy your presentation. I think it's a very brave and challenging task to do a database, and what you did is really impressive. But you collected already 200 patients, right, for your database. I am very curious, what is your final goal? How do you plan to complete this database? Because we talk a lot today about the importance of having your own database, and I'm curious about your final goal. How do you see it? Thank you.
Okay, this is a good question. What's the hypothesis about this? I think we are a little bit more ambitious, like Mimic doing is, we are more like the planning is like data driven, because we hope to collect all kind of data. So like the purpose of Mimic is they try to snapshot all the electronic health record of patient. Then like our NHRDB, then you will have the opportunity to testing the new hypothesis. So the answer is the proposal of this project or the goal is try to create a data mart for data-driven to search the hypothesis. But we do have some specific hypotheses we want to test it. I think the first one is we want to cooperate. We want to build up the model, multi-modality model to predict the 6 months recovery outcome. Yeah, that's one of the specific goals we want to reach, because like so far as I know, like published on 2019, the Columbia group, they only use the EEG solely. Then previously they have some like the image only and also some biomarker only. But probably after we collect enough the good quality data, probably this will be one of the some paper they do have some multimodality, then they have the ability to predict the patient outcome. Then we try to, actually we are trying to do the neuroprognostication. Yeah, that's our goal.
Anyone raise another, Dr. Lee, Professor Lee?
Yes, I think it is a very important and good projects that especially in the congratulations for the success in the NSTC's smart hospital, especially with the neurosurgicals or neuroscience projects toward the stroke centers. And I think just now, Dr. Lee, you mentioned that you established protocols that imprint through different centers, including home cares with the Xiaozhongzhens, and across different settings, even though we have same protocol, but inevitably that data collect from different settings might have discrepancies. And how would the data set predictions using the AI model, especially that we can apply across different settings, it seems to me is a very important task or challenges that toward the outcomes of the patients. That and with that, how do you think this supersets of the data from the ICUs then extended, applied toward the home settings in the future? That I imagine most of the patient might gradually recovery from in the home settings or in the care facility instead of in the hospital down the road. Yeah, thank you.
Okay, thanks, Professor Lin's question. The question is, since we collect data from different institutions, whether there were any bias. They have different level to discuss this. The first thing is the lab data or the biometric of patient data is kind of standard. You can argue the laboratory tests have some bias, but for those things, we assume they are more standard. But I think one thing is the stimulation-based EEG. So in this moment, to avoid this, we decided in the Taipei area, they were done by the same team. So to reduce the bias, like the quality of the EEG lead, so on. We at the beginning we believe that will be a bias. So we will train the same team to doing this and using the same device. Also, the whole experience protocol is designed by a software. So basically, you just set it up. Then we also have all the photo recording. So that's something we will try to avoid. Is when we look at the data, we will go back to examine the real situation. So we record everything, including the wire and also the screenshot of the computer. We also do the screenshot recording. Is in the case when we analyze data, if something correlated but is not really related to a clinical condition, then we will do that. And another thing is that will be hard is the comatose recovery scale, because that's done by human. So right now, in this case, I talked to my assistant, say we have to do that, evaluate in person. So that's one thing is to avoid, but it's expensive. But I think that is the only one way to guarantee that, because especially because I'm a neurosurgeon, we know even our new resident, they cannot do the evaluation quite well. So in this case, hopefully we will use the same team to do the evaluation. But yeah, this just very similar the idea, like the Dr. Leo said, that there could be a lot of bias. So like the EEG lead we use CAP and also use the lead. We asked the company, they say there's no difference, only if you document the conductivity. But I believe that still can be a bias, but we record all the parameters. So that is probably something, some side project we can come up with that during this kind of large scale, whether we will have some heterogeneous between the institution. But eventually, we hope to generalize the purpose. So something biased, something that could be, we are interested to observe. Thank you.
Add some information. Please go back to the slide of our data set.
Yeah, 15、16张这个夫妇的 data set， 有个3500个人。Can you slide show?
Slide. Okay. Yeah, this one. We try to establish a dimensional data set, including the neuropsychology test. This test also including neuropsychology inventory. So if the patients are at the risk of a psychosis behavior problem, when this patient admits to this hospital, the doctor in charge will receive a message. Your patient can get endorsed in your ward, or have a delirium, hallucination in your ward. So these patients can admit to any disease department. So the doctor can know this patient is at high risk in the ward. So this is also a smart hospital administration part. And this is this clinical data set. Actually, this idea is from the Minister Chiu Wen-da. Professor Chiu tell me, Tao Rong, you should have trace back this patient's medical record. So this data is not a prospective data, actually including the including the retrospect data. So this data including the patient's maybe 20 years electronic medical record, even before the dementia onset. Okay, so answer the questions SCD algorithm. We try to use this data to find some indicator to make an algorithm to predict the patients with developed dementia maybe 5 years before the symptoms. So, okay. And this, we joined the Davos Alzheimer's collaboration. This program is supported by the World Economic Forum. This forum is many rich people from the world. The only one person in Taiwan can join this forum is Cai Mingxing, the president of Fubon 集团. Okay, so this program is very rich. And actually, they want to make a so-called global cohort. They found the dementia research in the previous dementia research usually conducted in the Western country. So they want to promote the dementia study in the low economic social countries. They found the solution is that because the neuropsychology test or blood test are too expensive to them, so they try to conduct a so-called digital biomarker. They try to use the smartphone to record the gait, the eye movement, the speech to predict or diagnose the dementia patients. So we joined this program, and they sent us some tools to correct the digital biomarker. Yeah, maybe the digital biomarker is a trend for the dementia diagnosis and the prediction in the future. Okay. Thank you.
Thank you. Also, thank you, Dr. Hu's sharing. And any other question? Or maybe we should move to the next section, panel discussion. Yeah. Thank you. Thank you, Dr. Lin and Dr. Hu.
So I think we will move to the panel discussion. Then we will invite the panelists all come to here. Yeah, I welcome all the attendees. You can come forward. I think the style of this, we want to have some conversation. We can have some exchange of the idea. Okay, so I think the goal of this project is, I think, the connecting the people. I think, like we already hear some lessons, some others research. I think the most important thing is what's the next step. So I will maybe we will start from the right side, because then from the Professor Lin. I think the important thing is we can talk about what's the next. Yeah, because it seems like we have a lot of opportunity. We can see each other, work with each other. So probably we will, for each one by one, we can think about what's the next. Then we can start to organize the next meeting.
I would like to express my gratitude to Professor Lin and TMU and Shanghai Yuan for organizing this symposium. This is the first workshops of the series that we discussed. So we will continue these conversations and cooperations to the future goals of common, and especially with the massive amounts of the data and efforts already devoted by your team here, that we would like to extend the cooperation. As you know, that ICHIT is that, and especially our Taiwan's industrial efforts more or less concentrate on the hardware side. And today we have discussed and seen that clinical science that has tremendous amounts and efforts in treating the patients, and just now we talk about the dementias and also the brain injury patients, that in terms of the patient journey that we see the continual care does require integration efforts of the hardware and software, and from the data collected from the past retrospective and toward the future's recovery. And I think with the leadings from the clinical science that we can continue to discuss what priorities of the care and what areas of the needs can be fulfilled by this joint efforts in the near future. And looking forward to put in resources from the academic side and with our ICHIT from the Economic Minister of Affairs, and in the future probably we can link resources from the industrial side to form this cooperative effort together. Yes, thank you.
Next, at first I will thank all the organizers and also the committee for this meeting to have me here to share, to learn from clinicians and all the AI smart data collection analysis, this part. In my side, I am doing the regenerative medicine for more than 10 years, and I'm a cell biologist, actually. And I learned today is maybe in the near future, we can do regenerative medicine, especially the cell therapy or the implantable, inducible implantable device to based on the digital biomarker analysis and systemic analysis from maybe 10 years or 5 years to predict the therapy procedure, or maybe to design the therapy program or process to give the patient to have more healthy and to prevent the elder degenerative phenomenon in human, to have a good lifestyle in the elderly patient. It's my vision, and also in the near future, I hope we can join this integrated team. Maybe we are from different disciplines, but we can integrate to have a more vision of healthcare, more integrate and more great vision of this healthcare. Thank you again for all the committee and organizer for this great meeting. Thank you.
Thank you for the organization for this conference. I'm really glad to be here today because I heard of the dementia database from Shanghai医院, around 3,500 patients. As I mentioned earlier, it's a journey for the prevention of Alzheimer's disease. It's really a long journey. So for the prevention of Alzheimer's disease, I think we can collaborate with Shanghai 医院 or Taipei 医院 for the collection of data from the clinical side or from the digital science. That's why I'm interested at this moment. So as I heard about the eye movement, that's one of our projects. We are looking forward to collaborate with Shanghai 医院. So for the future collaboration, I think is the, for my expertise, I am quite interested in the collaboration for the dementia prevention in terms of a data bank or the data from patient or population base. Thank you.
Thanks, the organization invited me to join this very interesting and very productive meeting. I think the medicine is changing. More and more discipline join this field, and we have to learn and learn. It's a little heavy burden, you know. In the before we just see the patient and prescribe the medication, but right now more and more information comes in and to allow us to take a look at the data and a lot of information and signaling. So this change should be good for the patients and should be good for the physicians. So we, in the future, I hope there is an ecosystem for the medical care. In this ecosystem should be included the academic field, clinical field, and industry. So, but in the ecosystem, this should be a platform to integrate all the these stakeholders. So I believe under the leadership of Dr. Li Mingjin, we can build a very good platform, and especially for my interest in I hope dementia patients can be cared better. So I hope in the future we can recruit more and more like industry or academic experts to this field. Yeah, it's my hope, and I count Dr. Lin to build this platform. Thank you.
I'm Dr. Chen. I'm a neurologist specialized in stroke. So that means a strokeologist. First of all, I have to thank you very much for inviting me to join these panelists. In my clinical practice, most of the patients come to our patient clinic because we have to make the secondary stroke prevention. In the area of precision medicine, I think we need to do more individualized treatment plan for our stroke patient. As we all know, the dementia patient, most of the dementia patient is due to the Alzheimer's disease, but the vascular cognitive impaired patient is keep increasing. Most of them may cause more severe disability than pure stroke patient. That may cause many family burden. So I think in the future, this platform will give us a very good communication for discussing the future, for example, the stem cell therapy, where we have just accomplished phase 1 stem cell therapy for acute stroke patient. The result is quite good, so we close earlier. Okay, maybe in the near future we have maybe we can focus on how to give the patient more individualized treatment plan for the patient and also for the family. And also how we use the wearable device for the better hypertension, diabetes, and complication management. I think we will see. I think this platform will go to work. Thank you very much.
Thanks all of you coming. I think every meeting they need to have some conclusion and some actionable action. So I'm thinking that. But I believe the education and doing some research together, that will be some very good benchmark to evaluate our cooperation. So because the ICHIT, I feel it's also kind of academic research organization. Then we know there are some NTU and the Seneca, they have some joint program also, and so on. And it seems like we are doing some similar thing. Then I guess you will appreciate they are some students they're doing together with you guys, and we also, yeah. So I'm thinking that probably after today's meeting, we can pull up some name of list, because in our TMU we're doing the same thing. We have some joint program. Then probably, like I also received students from different departments. So probably we can have a pooling list that, like for example, we know, like myself, I'm doing the EEG. Then I guess there are some EEG and some expert from the ICHIT. So if we can guidance the student together or doing some research, that will be some good thing. And another thing is like we know the NSC, they have a brand 就是脑的领先科技的一个计划。I think, yeah, today we try to submit. Then this is our some long-term goal that we can come up with the idea that we can help some clinical. So I have two proposals. One is how about we can start to guide students together, so like a kind of pair. Then we can have if some people from ICHIT you are interested, then we can find student, then or some clinician we can work together. That is like right now we already have something going on. So when we can, I can represent the biomedical informatics department. I think Professor Hu, he's from clinical department, clinical medicine department. I think we can put the student and ICHIT together, then we can pair the clinician and the ICHIT together. That is one thing. Then another thing is how about we can think about some big project like a brand, then come up with some idea. Yeah. So yeah, maybe yeah. For these two issues, yeah. So what do you think? Yeah, we talk about submit project together.
And in ICHIT, we have an urgency to include good expertise, a skilled person, because a lot of our person is attractive to the science park by IC industry. So if we can cooperation from the student lecture, student study, student research, it will be very great to facilitate our research and also to have some industrialized experience sharing with the hospital or the university here. So I think it's a very great idea. Maybe we can have startup to move on this project.
I think it is truly necessary, not only due to Leo says that each aspect has a bias that require more cooperative to solve the problem, but also in Taiwan we are very small and everybody is busy, but I think the communications between all the stakeholders is important, and this platform does provide good starting points, especially brain science or neuroscience in Taiwan has been putting effort for a long time, but I think the tools and scattering and people, I think it's a high-risk area, and it takes a lot of resources and time to initiate the first step. But I think this is a good starting point. But not only because all of us are more or less doing this for a long time, and good achievements already there. But also, I think the aging societies see the emergent needs of these solutions toward the patient's benefit. And I think definitely we're looking forward to working together, not only from the academic side for the NSTC's projects proposals, but also from the Minister of Economic Affairs side, that we see how we can bring the industrial resources together. And I think also TMU is also very active in the startup for the new technologies to spin off, and also ICHIT, the team is also working on this. And so we think it is a good platform to begin with. And then allow me to introduce Dr. Shen. She has allogenic mesenchymal stem cells, which has 2 clinical trial approval with the allogenic stem cells. So definitely, she just mentioned that today we didn't touch upon this, but I think it can be a good topic for the future discussions, how the stem cells can be used in the clinicals, especially toward the recovery of the patients in the brain with the stimulus response. And Dr. Wen, she is a neuroscientist from Durham, UK, and her expertise in the nature, but also covered the drug discovery, and this area in traditional Ministry of Economic Affairs is still very limited, and we try to see in the future that maybe both this area can be expanded. Of course, just mentioned there clinical trial in the biological drugs, but with a significant risk to the patients. Maybe alternatively, we can find other solutions together. Yes, thank you.
I think actually Professor Hu, actually he's my boss. I mean, he's current VP of the College of Medicine. Actually, I mean, all the education, clinical research is under his supervision. Probably the Professor Hu can give us some guidance that, I mean, we have these 2 parties. From your perspective, please give us some, yeah.
Found both sides are very strong, and there are a lot of topic can be worked together. So in the future, I hope we have a regular meeting and raise the issue. We can work together, and finally, we should apply some grants to get the funding to conduct our study. So it's the essential we have to do. Yeah.
And Dr. Lang Chen, he has a good connection with different field. He's kind of, I mean, he's kind of going enzyme or something, yeah, because he know people. Yeah, probably he can also give us some advice.
I think we should go on and collaborate together and make the stroke and also the dementia patient and their family a better perspective, better future. Yeah.
Okay. I think due to the time, yeah. But let me conclude that it seems like we know each other. Then we also believe. I 做中学啦, so I always believe we do some action. Then it seems like we have some people from College of Medicine and from graduate biomedical informatics department, and also the doctor. Then we will prepare a group of list 人才库, and we will also work with ICHIT, because it seems like we have a lot of project like the OCT, the robotic, and brain DBS. We have share some common interest. So yeah, then we also have some good,工作人员 Grace Huang. Yeah, we thanks a lot. He's kind of another 灵魂人物, and Edward still here? Yeah, Edward. Yeah, they are also, these two guys, they are really the true organizer in behind, and they are also very good at organizing team. Yeah, actually the Smart Hospital project is all with their help. So yeah, in the future, I think after this, I will summarize things. Then I think I will try to come up with a list of person and share the interest. Then I think we can facilitate in the future. I cannot remember the first time I met Professor Lim, but maybe 2-3 years ago. But actually, each time we see each other, kind of excited. We always have something new want to say to each other. But so, how about let's become a regular thing? Then, with all these people supported, then we will come up with some research and a big project together. Okay. So then, any suggestion, question from? Oh, okay.
Sorry. Here is an online question for Dr. Lin, and the question is: during measurement, how to remove individual difference, and among the many variation, how to define that is the main reason?
For my research, okay. Yeah, people keep asking me how to justify the heterogeneous of human, and some advice, some reviewer from NSC, like Yang Panzi, they asked me, yeah, there's a lot of human heterogeneous, and how many number that you can justify to normalize the bias. Then usually for the machine learning, like if you do the image, usually it's like a 10K, yes, E1. But I give another. I use the Columbia's data set as my justification. Is in Columbia's data set, they only use 104 patients. Then they got a significant result. So yeah, this is a good question. Is heterogeneous of patient, that would be a problem. The first thing, we document everything. We try to, because they have some confounding factor over there. But so we document, try to document it, and we analyze the data carefully. But the second thing is, based on the current data set, actually the Columbia data set, 100% is already big enough. There are some paper published on brain psychology, they use the EEG and so on. Actually, they just use around 20, 30 something. So, because it's hard to get those the patient. I mean, without all this cooperation, yeah, I'm really thanks neurology department. They are even myself here, neurosurgeon, but I work more closely with. I shouldn't say this public. But anyway, you can see this kind of cooperation. Everybody, they willing to join this data and to make this success. So yeah, so probably we try to gather in more data. Like the people say, we will have data from NTU and the Hualien. One of the purpose is to do the external validation, yeah, to avoid the bias.
Maybe I'd add on to this. I think it's inevitably there are structural variations. So this is the first step to collect the standard with standard protocol. But the data discrepancy along the patient journey definitely will happen. And so we do require certain internal markers in terms of the digital biomarker. I think Professor Lin gave it a good, using the stimulation response, I think it can be used to normalize the variation significantly. So I think that would depend on the software size to do the data processing. And so structurally and also computer software can help to minimize those variations. And so I think this is an important first step to working together to get forward. Yeah. All right. Yeah. Thank you.
Yeah, I really appreciate this comment. I mean, yeah, this more elaborate. I mean, we only use one approach, but in the future, whether we can using the different approach to minimize the heterogeneous bias, that will also a kind of research issue. Like yeah, because we just have chat. We say they have different protocol. Like because right now our protocol it takes about 25 minutes. So in the future, maybe just use some pure tone and some special light wave and much more. Then probably we can come out another startup. We can really create a feasible commercial product to measure it. Yeah, thanks. Okay, so I think we should be on time. Efficiently is so important of the quality of this talk. Yeah, so thanks everyone. Then thanks for coming today. Yeah, thank you. And thank you all. Thank you.